Welcome. In this video, we're integrating 1 over the square root of 1 plus x squared. This integral is of the form root a squared plus x squared, so we're going to use the substitution of x equals a tangent of theta. In our case, a equals 1, so x just equals tangent theta, which means x squared is equal to tangent squared theta, and dx is equal to secant squared theta d theta. So now we can rewrite this. In place of dx here, we will write secant squared theta d theta, and in place of x squared, we'll have just tangent squared theta. So this is the integral of secant squared theta d theta divided by the square root of 1 plus tangent squared theta. Now recall, 1 plus tangent squared theta is equal to secant squared theta. So I'm going to replace this 1 plus tangent squared theta with a secant squared theta. And this will give me secant squared theta divided by the square root of 1, not 1 plus, just secant squared theta inside the radical, d theta. So this becomes secant squared theta over secant theta d theta, or just the integral of secant theta d theta. If you've been following along with my Canvas course or with this YouTube channel, you've already seen this integral derived. There should be a link coming up on your screen right now. Please click on it if you want to see the video of how this is derived. So this is just the natural log of secant theta plus tangent theta plus c. And I'm going to move that over here really quick. Why am I doing that? Because I need to leave a space for some right triangle trigonometry. Namely, we started with x's and we have thetas, and we need to fix that, and we're going to fix that with trig. Okay, so there is my messy-ish right triangle, and there's the angle theta. We decided, that is, we made the decision to let x equal tangent of theta. So in essence, tangent of theta is equal to x over 1. And if you recall, tangent is opposite over adjacent. That tells me that this side opposite of theta is equal to x, and the side adjacent to theta is equal to 1. So using the Pythagorean theorem, you can see that this is just 1 plus x squared inside the radical. Using the Pythagorean theorem, you can just see that this is 1 plus x squared inside the radical. Okay, so how does this help us? Well, already I know I can replace tangent theta with just x, since that is the substitution we made. But what about secant theta? Well, secant theta is equal to 1 over cosine theta. And from this triangle here, I can see that cosine theta is equal to 1 over the square root of 1 plus x squared, since cosine is equal to adjacent over hypotenuse. Secant being its reciprocal is equal to just 1 plus x squared. So replacing secant theta with the square root of 1 plus x squared, and replacing tangent of theta with just x, we end up with the natural log of the square root of 1 plus x squared plus x plus a constant c. So this integral evaluates to this right here. I hope this video is helpful.